Details of the day. In this video, we will discuss array operation. In the previous video, we have discussed in detail about what are arrays, the features of arrays, the application, and the common pitfalls that we could encounter while using arrays. In this video, we will look at the various programming aspects and the various operations that we could perform on arrays. In C programming, arrays are used to store multiple values of the same data type under a single name. Array operations involve various tasks such as initializing, accessing, modifying, and manipulating elements within an array. What are the need for modifying array elements? Arrays facilitate efficient storage and manipulation of large data sets in algorithms for data processing. Arrays are employed to store and manage user-provided data, facilitating interaction in the programs. Arrays also serve as the fundamental for advanced data structures like linked lists, enabling for flexible storage and retrieval of information. Arrays also aid in representing and simulating real-world systems, crucial for modeling and simulation applications. Arrays play a role in error detection and correction algorithms, helping to manage and rectify errors in data. Arrays enable the dynamic management of input-output data, crucial for adapting to varying programming requirements. Hence, it is very essential to understand the various operations on elements which finds applications in the all about discussed scenarios. The first operation on arrays is array traversal. Array traversal is the process of systematically visiting each element of an array, typically using a loop, to perform specific operation or gather information about the elements. It involves sequentially accessing and processing individual elements, starting from the first element and progressing through the last. Array traversal is a fundamental task in data analysis, manipulation, and retrieval, as it allows for systematic examination of each element within the array structure. Now let's look at an example for how to traverse an element inside an array. So here is an example array. We know that the indexing of an array starts from 0. Here is a for loop which starts from 0 till n minus 1, that is 4 in this case. So each time when I run a loop, I am changing the value of I, which enables me to traverse through this list. In this program, we are printing each and every element of this array. So let's look at the result of this program. It is also possible that we could do some changes to this program. So let's assume I want to add. See, in the first case, let us just display the elements of an array. Later, we will also do some modification to the array. Let's assume I need to multiply this by a factor. So let me define a factor. For example, my factor is 3. Let's assume that inside the for loop, I am required to multiply each of my element with this factor and then display the values. So you can see that each element of an array is multiplied by, so I need to provide the index, that is I. So each element of my array is multiplied by a factor of 5. So this is the process of traversing an array using the for loop. You could either print the elements or you could do some operation on every element. The next example that we could think of is concatenation. Array concatenation is the process of combining the elements of two arrays to create a new array. This process involves appending the elements of the second array to the end of first array, resulting in a larger array that contains all the elements of both the original arrays. Array concatenation is often used to merge datasets, facilitating the creation of a unified array that retains the elements of individual elements in their order. This operation is used in applications like combining datasets or extending arrays or to accommodate essential additional information. So now let's look at a program to concatenate two arrays. So let's go to the compiler and we will write a program to concatenate two arrays. So let me take two arrays. The first array, let me name it as my array 1. So this has 5 elements. Let me take my second array, which I will name it as my array 2, and I will insert new set of values into my second array. So the purpose is I need to concatenate these two arrays into a new array. I will call it as combined, and this array has a size of 10 because it needs to accommodate the elements of the first and the second array. Now let's declare some more variables. For example, I need I to iterate the loop, and I need one more variable ij. Next, I need one variable L1 to calculate the length of first array and L2 to calculate the length of second array. So now what is the first task? See, I need to know the index or how many elements are present in the first array. So how do we calculate is I will take one variable called as, and we know that the initial sizes of L1 and L2 is 5. So let's assign them. L1 is equal to 5 and L2 is equal to 5. So initially, I will take my j to be equal to 0. Then inside a loop, I will run my loop from I is equal to 0 to I less than the first length and I plus this. So what am I going to do here is I will add the first element of the combined array of I is equal to the first array is equal to, so this is j. And each and every time I initialize, I will increment the j to point to the next index. So this will move the index of the j till the end of the first loop. Next, I will now start traversing my second array where I will iterate till N2 and I plus plus. Inside this, I will be adding the combined copy, but in this case, I will be adding my second element values to the resultant list. And once I am done with the concatenation, so we can just print the combined values for I is equal to 0 till I less than 10 because we have 10 elements I plus plus. So what am I printing here is the content of my resultant array. That is percentage d with some space. I am printing combined of I. So let's check the result of this array concatenation program. You can see that we have concatenated two different arrays. So this is an example task on array operations. Let's understand the concept of copying. Array copying is the process of duplicating the elements of one array into the other. This operation involves iterating through each element of the source array and copying its value to the corresponding position in the destination array. Array copying is very crucial when you want to create a duplicate or a backup of an existing array without altering the original data. It ensures that the content of the source array are replicated in a new array, allowing for independent manipulation or analysis of the duplicated data. This operation is fundamental for various programming tasks where the preservation of array content is necessary. So now let's look at an example program how the values of one array could be copied to the values of another array. So we have original array. So I am calculating the number of elements in that array. See here the point to observe here is I have not specified the size. So the size is automatically calculated using the size of operator. Next step is to create or declare a new array of size which is equal to the original array. This is the array to which the original data has to be copied. Here we are traversing the first array and copying the data of original array into the corresponding index of the new array. And then we are printing the original array as well as the copied array using the for loop. So let us run the code and observe the result. This program is made independent with respect to the size. You could provide any number of elements in the list. So I will show you the example for it. So we have the original array and the copied array. So let's assume I have 10 elements. The same operation is going to happen. So this is the advantage of making the use of size of operator to calculate the size of the array. The point to note here is the size of an array is not specified when the initialization happens during the declaration process. So let's see the result now. So we can see that we have 10 elements copied from the original array. So this example makes us clear about how to copy the elements from one array to the other array without having affecting the original array. Next operation is insertion. Array insertion is the process of adding an element or a set of specific elements in a specific position within an array. This operation often involves shifting existing elements to accommodate new data. When insertion of when inserting an element, the element and after the insertion position may be shifted to make room for new value. The insertion point is typically identified by an index or a position where new element needs to be added. Array insertion is fundamental for dynamic data management, allowing the expansion or modification of an array contents as needed in the program. So now let's discuss two important points. The first one is inserting at a specific index or inserting at the end. So now let us look at the example program where we are inserting an element at certain index which requires shifting. So let's understand. Here we are declaring the original array. We are calculating the size of an array which will tell us the number of elements in the array. The element that I want to insert is 10 and the index at which I want to insert is 2. So the first step is we have to validate the index, right? So the index at which the element has to be inserted should be greater than 0 and less than the size. If this condition is violated, we can raise a error message saying that there is a the index is invalid. So now it is very important that I need to create a new array with the size which is equal to the previous size plus 1 because I want to insert another element. So the procedure that we are going to follow is copy all the elements before the index using the array traversal. Insert the new element of the particular index and then copy the elements after the index. So this is the drawback of using arrays because if you want to insert a particular element at specific index, it is required to do some necessary spacing to include a new element which has more time complexity, which we will discuss in the end. So the procedure that is followed to insert a specific element is copy all the elements before the index, insert the new element and copy the elements after the index. And then we are printing the original array and the array after insertion. So let's look at the result. See, the task of this program was to insert element 10 at index 2. So we can see that 10 is inserted at index 2. So this is an example program to understand how to insert a new element at specific index. Next, let us see how to insert an element at the end of the string. When we need to insert the element at the end, the shifting process is not required. So the initial steps are very similar to the previous one, but the element is inserted at the end of the string. So we have the original array. We have calculated the size of the array. The element to be inserted is 10. Next step is to create a new array with the increased size. Copy the original elements from the original array using array traversal. Insert the element at the end. So finally, we are able to print the new uh, new array which has the elements which has the element that is inserted at the end. So we can see that 1, 2, 3, 4, 5 is the content of the original array and 10 is the element that is inserted at the end. So this example illustrates the insertion of element at the end of the array. So insertion forms one of the most important array operation. Let's look at array deletion. Array deletion refers to the process of removing an element from a specific position within an array. This operation involves shifting the remaining elements to fill the gap created by the removal of the element. The deletion point is usually identified by the index or the position of element to be removed. After deletion, the size of the array is reduced. The elements following the deleted elements are shifted to occupy the vacant position. Array deletion is crucial for managing and modifying array data, allowing for dynamic adjustments of array contents during the program execution. So unlike array insertion where the size of the array was increased, in case of array deletion, the size of the array is decreased. So now let's understand the example program for deleting an element from the array at a specific index. So here is an example program. So as discussed in the previous uh, slides, we have the original array. Now let us say I want to delete the element at index 2. The first is to validate the index. So this is a very important step to avoid invalid indexes. Next, we are creating a new array with the reduced size. See, in the previous case, we had a new array whose size was size plus 1, but here we have size minus 1. What are the steps that are followed to delete an element from a specific index at a specific index? Create a new array, copy the elements before the index, and continuing copy the elements after index. So we are overlapping the element at the specific index and hence we are deleting the element at the particular index. So let's look at the contents of the array here. 1, 2, 3, 4, 5. We need to delete the element at index 2. That means we are deleting 3. So when we execute the code, we should see the resultant array where 3 is deleted. So unlike the insertion program, the size of the resultant array is reduced. So we can see that the element 3, which is positioned at index 2, is deleted from the original array. So far we have discussed array traversal, array concatenation, array copying, array insertion, and array deletion. So under deletion, we have also deleting by value. Let's assume I want to delete element 10 from the new array. How could how could we do it? So let's look at the example program for it. As discussed in the previous programs, we have the original array. Now I am not specifying the index. I am specifying the value that has to be deleted, that is 3. So we are going to traverse through the loop, traverse through the array to check if the content of the val is equal to the value to be deleted. If the value to be deleted matches with the value of the array during the traversal process, that particular index is stored. Initially, the index to delete is taken as -1. So this is done in order to have a scenario wherein if the element to be deleted is not found in the array, then once the index of the element that has to be deleted is found, then the procedure that we followed to calculate or to insert the element at a particular index is followed. If the index to delete is equal to -1, it means that the element was not found. If it is not -1, that means the element is present and the same procedure that was followed to delete an element at specific index is repeated to delete the specific value from the array. That is, a new array is created with reduced type. Elements from before the index is copied and elements after the index is copied. So now let us check the result of this program. So we can see that now the element 3 is deleted. Instead, if I say that the value that I want to delete is equal to 10, then you will see that the element is not found for deletion. The process involves finding the index of the value to be deleted and then copying the elements before the index and after the index. So now that we are clear with array insertion, array deletion, we will move on to some more operations on arrays. The first operation is finding the maximum and minimum in an array. So what is the logic behind finding the maximum number in an array? We have a set of values defined in an array. We set the maximum element, the maximum value to be equal to the first element. We are checking if this value is greater than the next element. If the value in the array iteration is greater than the max is set to be equal to that element. So during this traversal, we are able to find the maximum element in the array. So let's check the result of this program. Similarly, what is the logic to find the minimum of an array? The minimum of an array is said to be equal to the first element. In traversing the array from the first and second element till the end, if the value is less than the minimum variable is set equal to the corresponding array element. So now let us check the result of this program. So we can see that maximum is 9 and minimum is 1. So this is our array data set. So array traversal plays a very important role in the operations or in writing programs corresponding to arrays. Next, let us see what is the logic to reverse an array. To reverse an array, it is required that we copy the elements from the end of an array, right? So we take a temporary variable and we just go on exchanging the first and the last elements. The first half and the second half elements, if they are exchanged, it means that the array is reversed. So you know that we require a temporary variable for exchanging the array elements. Here is an example. So we have an element array of size 5. How do I reverse this? The first and the last elements need to be exchanged. The second and the fourth element needs to be exchanged. And that is what is happening in the for loop. The for loop is going to iterate for size by 2 number of times. If we have 5 elements, then we require 2 exchanges. If I have 6 elements, I would require 3 exchanges. So let us take an example with even number of elements and odd number of elements to understand this. In this example, we have odd number of elements. So I would require 2 exchanges to happen. So let me run the code and show you the reversed array based on this exchange logic. So we can see that the elements are exchanged. So now when I have even number of elements, so that means I have 6 elements in my array. So 6 by 2 will give me 3, which indicates that there are 3 exchanges required to reverse the array. The advantage of this method is that it is not using any additional memory. So you can see that the array is reversed. So the point to note here is the logic works fine for both odd number of elements and even number of elements. The number of exchanges that is required is given by number of elements by 2. The next operations that we could perform on array is searching for an element. Whenever we need to search for an element, it is required that we keep one variable called as flag or found to indicate the result of our search. We have an exclusive session on searching and sorting algorithms. In this video, we are just going to understand what is a linear search. And found is a variable that is used to indicate the result of the search. We are traversing through the elements of an array using the for loop. If the element of the array matches with the element to be searched, the found variable is made equal to 1, indicating the success of search, and the loop stops because it has found the target. If the target element doesn't match with any of the elements of an array, the found value is never made equal to 1 and it remains at 0, indicating the failure of search. The found variable is then the found variable is then tested. If it is equal to 1, that means the element is found, else the element is not found in the array. Now the value that I want to search is 6. So let me run the code and show you the result. Element 6 is found. If my value is 66, which is not present in the array, you will see that the result is the element is not found. The point to note here is the new variable, or we call it as a flag variable, which is used to indicate the result of the search operation. This process also utilizes the array traversal process for testing or for checking the target variable with elements of an array. The last operation that we have in this video is to calculate the sum and average of the array elements. Similar to the codes in the previous programs, we have the elements of an array defined, and whenever we are calculating the sum, it is set to 0, because if the value of sum is not initialized to 0, initially the variable sum will contain some garbage value, and the addition is going to happen over the garbage value. So it is very essential that we set the sum variable to be equal to 0. Inside the array traversal loop, we are adding the elements of an array to the sum variable successively in every loop iteration. And at the end of the loop, we are calculating the sum of, we are printing the sum which was calculated inside the for loop. Next, we are applying the average formula, which is given by the sum divided by the number of elements, and printing that sum with a precision of 2 decimal points. It is very important to note that a type conversion is required, because if we have two integer values, it will result in an integer division. For example, I have 3 by 2. See, 3 is an integer, 2 is an integer. This would result in integer division, giving me a value 1. If I want a floating point division, it is required that either the numerator or the denominator should be a float value, which results in a floating point result. Hence, it is required that I convert this sum into a float value so that I am able to get a float average or a perfect average value. Now let's look at the result of this float. So we can see that sum is 30 and average is 6. So now let me change some of the values here to understand the precision parameter. So here is the average, which is displayed at 2 points precision. So similarly, using array traversal process, it is possible to do, it is possible to calculate any mathematical formula inside the for loop. So this was some additional operations that could be performed on arrays. Just summarizing, we have discussed about array traversal, which is nothing but visiting each elements of an array, which is done using the for loop. Next is the process of array concatenation, that is combining two arrays into a single array. Next, we have seen how to copy one array into another array. We have discussed about array insertion, Under this, we have discussed two scenarios, that is inserting at a specific index and inserting at the end. Array deletion is possible by two ways. That is, one is deleting the element at a particular index or deleting the specific value inside the index. Next, we have discussed how to find the maximum and minimum in an array, how to reverse an array, how to search for a particular element in an array, and then how to calculate the sum and average of an array. So, after having understood all the operation, now it's the time to understand what is time complexity. So, how do we define time complexity of an algorithm? In programming, the time complexity is the amount of time it takes a sequence of code or an algorithm to execute how to perform some specific operation. So now let's understand the time complexity of various operations on arrays. The first operation is accessing an array element by an index. See, it is very easy to access the elements of an array by index. If I want to access the third element, I can directly say array of 4, array of 3. So it requires a constant time. So which is indicated by O1. The next operation is inserting or deleting at the end. See, insertion and deletion at the end also requires a constant time because we can directly write it using one line. We need not iterate any loop for inserting or deleting the element at the end. If I want to insert or delete in the beginning, it requires to shift all the elements resulting in a linear time complexity. So the time complexity is indicated as OM. If I want to insert at a specific index, that also would require the same time complexity. The next operation that we are going to discuss is searching mm, for an element when we have an unsorted array. So binary search applicable to sorted arrays halves the search space at each step, resulting in logarithmic time complexity. So the worst case is given as O of n, assuming that the element is present at the last. Then, what is the time complexity if the elements are sorted? When the elements are sorted, it is the logarithmic time. So it is very important to understand the time complexity for searching for a sorted array and unsorted array. What is the time complexity required for sorting? For efficient algorithms like merge sort and quick sort, array typically requires comparison based algorithm resulting in average and worst case time complexities of n log n. If I have 8 elements, so copying an array from one to requires traversing of the entire array, leading to the linear time complexity. So it is very important to understand the various time complexities for different operations on arrays. Similarly, let's understand the space complexity. Space complexity refers to the amount of memory space required by an algorithm or a program to execute in relation to the input space. For array operation, space complexity is influenced by the additional memory used for variables, data structures, or the resources required during the operation. Accessing an element doesn't require any additional memory, and hence it has a constant space complexity. Inserting or deleting at the end also doesn't require additional space. Hence, it has constant space complexity. Similarly, inserting and deleting also would not require the additional space. Sorting an array would require a space complexity of log, log n because it would require additional space for storing temporary data or temporary variables. And similarly, copying an array would require a space which is proportional to the number of elements in the array. So, understanding time complexity and space complexity is very crucial in building efficient systems. So, concluding, when we are working with arrays, accessing individual elements or sub-arrays by specifying their position or range within an array, we perform element-wise operations while we are doing addition, subtraction, multiplication without the need for explicit loops. We can aggregate the values of an array like sum, mean, max, min, etc. Reduction operations will collapse the array along the specified axis, reducing its dimensionality. Insertion increases the dimension and deletion reduces the dimension. Automatically, broadcasting automatically exists the shape of smaller arrays to match the larger arrays, facilitating element-wise operation between the arrays of different shapes without the need for explicit conversion expansion. So, this session has summarized the various operations on arrays, and we have also seen the codes for performing the various operations. In the next video, we will discuss about multi-dimensional arrays and the various operations that could be performed on multi-dimensional arrays. Thank you.